Alright, here we're trying to design a voltage divider. So we're going to start with a 9-volt battery. We're going to have to pick a couple of resistors. That's where our load would attach. So we have an R1 and an R2, and if I were to attach a voltmeter here in the open circuit condition, it should read negative 5.5 volts. So we've drawn a schematic. We just have to figure out what these are and then do the calculation to show that that worked. So I'm going to start with the open circuit load voltage equation that we use. Oops, it's load. That's Vs R2 or R1 plus R2. So what do we know so far? We know that load voltage is going to be 5.5 volts. This is going to be 9 volts times R2 over R1 plus R2. Now the problem is that there are two unknowns here. I don't know R1 or R2, so I can't use one equation to solve for both. What I can do though is pick one value and then solve for the other one. So since R2 is in two places, I want to make my life easier if I pick it, so I'm just going to arbitrarily call it, let's say 100 ohms. So if you make a different choice, you're going to get a different R2 value or R1 value from me. That's okay. There are many ways to solve this problem. I'll call that 100 ohms, R1 plus 100 ohms. Okay, and now I'll solve for R1. So I'm going to multiply both sides by R1 plus 100 ohms. So I get 5.5 volts times R1 plus 100 ohms. So this up here I'll multiply out and I'll get 900 volt ohms. The units don't cancel nicely. If you look at Ohm's law, delta V is IR. So a volt is equal to an amp times an ohm. But volt times ohms, it's nothing nice, but you know, the units are what they are. So 5.5 volts times R1 plus 550 volt ohms is 900 volt ohms. 5.5 volts times R1, subtract it over, that's 350 volt ohms. Divide both sides by 5.5 volts. R1 is 350 volt ohms over 5.5 volts. Notice the volts will cancel out and I'll get a number in ohms, which is good because I'm solving for resistance, right? So if these units didn't cancel correctly, I would be sure that my answer was wrong. 63.6 ohms would be R1. Okay, so my voltage divider has R2 of 100 ohms, R1 of 63.6 ohms. I want to demonstrate that it does the desired job, so I'll plug it back into my equation, make sure everything works out okay. I get 5.5 volts, which is what I wanted. So this will work. In fact, anything in this ratio of 0.636 to 1 or 63.6 to 100, anything in that ratio will work. So when you check your solution, check to make sure that you have that ratio. Okay, so will this do better with a high resistance load or low resistance load? High resistance load will be better because it will disturb the circuit less. In fact, that's one of the deals with the voltmeter. You always wire the voltmeter in parallel. The voltmeter itself has a very, very high internal resistance, so very little current goes through this branch, meaning it disturbs the circuit very little. So the same concept that goes with the voltmeter is true for the concept for the load of a voltage divider. High resistance disturbs the circuit less in parallel. When you plug in an ammeter, you want a low resistance because that's plugged in series. And will it be more efficient with a low voltage, low resistance load or high resistance load? It's actually more efficient with a high resistance load. With a low resistance load. That is, more of the power delivered by the battery goes to the load instead of to the voltage divider. But even though it's more efficient, the voltage delivered to the load is wrong because it's a low resistance load. So efficiency isn't really what we're going for with the voltage divider anyway.